Hi there. We talked today in class about the first derivative test. And the first derivative test allows me to find the intervals on which a particular function is increasing or decreasing, as well as to help me locate the relative extrema of the function if it does have any relative extrema. So hills or valleys. Right, and so the first derivative test works as follows. First of all, you want to make sure you're looking at where your discontinuities are. That might be a break in an interval potentially for our increasing, decreasing intervals. And so when I'm looking at this function, I'm going to see, do I have any place where the denominator equals 0, a place where my interval might break? And with this particular function, I don't. So the next step is going to be, do I have any critical numbers? Right? For the sake of my particular derivative, I'm going to go ahead and distribute that negative in before I take the derivative. Just manipulating the function a tad. I don't have to, but I'm going to choose to. And so then I'm going to take the derivative here. Got f prime of x equals, this will be negative 2x minus 8, and negative 10 is a constant, so its derivative would be 0. And once I've got the derivative, I'm going to set that equal to 0 to find my critical numbers. Now I would want to be aware of any possible not differentiable spots. Usually that would be the edge of my domain in a square root. Like if the derivative had a 0 in the denominator, it might indicate the edge of my domain. And I would probably want to take that into consideration on my number line so that I could see where my intervals would actually be starting, because I would have a restricted domain in that instance. Okay. This particular one, that we have no denominators to equal to 0, so we've just got negative 2x minus 8. And so I'm going to go ahead and solve for x here, adding 8 to both sides. We get negative 2x equals 8. And dividing by negative 2, we'd get x equals negative 4. And so that's my one critical number. So I'm going to go ahead and set up my number line. And I'm going to put my critical number on my number line. And if I had had any discontinuities, they would make their way onto my number line as well. Any number you have would go on the number line. Any discontinuity or critical number, that is. Okay, once you've arranged those all on your number line, you're going to be testing a number in every interval that you see on here. In this particular case, I've only got 2 intervals. It is possible to have more than that. So in these 2 intervals, I'm going to go ahead and pick a number. Left of negative 4, I could pick any number I wanted. I'm going to go ahead and pick negative 5. And that negative 5, I'm going to be plugging into my first derivative to see whether I get a positive or negative. If I get a positive, then I know my graph is increasing because my slope is positive, and a positive slope makes your graph go up. If I get a negative number, then I'm going to know that my graph is decreasing because I have a negative slope, and a negative slope makes a graph go down. Okay, so taking that negative 5, I'm going to plug it into my f prime up here, and I'll get 10 minus 8, which is a positive number. And so this means this function is increasing on that interval. Okay, and then right of negative 4, I can pick any number. I'll go ahead and pick 0. And 0, when I plug in, I get negative 8, which is a negative number, and so I know my function is going down. It's decreasing on that interval. Okay, and so then in number 14, we were asked to indicate what intervals we were increasing and decreasing on. So we are going to be increasing on the interval. I'm looking at my number line here. I'm increasing on this whole interval, which starts out here at negative infinity and goes up to negative 4. And I'm decreasing on this particular interval, which starts at negative 4 and goes all the way out to infinity. After locating those intervals, I was then asked to evaluate or to locate where my relative extrema are. And in this case, I have no relative minimum, because a relative minimum occurs when a valley is formed, and when I'm looking at this number line, I definitely see that that is not a valley. That is a mountain, a hill, and so that is a possible relative maximum, right, at negative 4. But if we want to verify that it is in fact a relative maximum, we need to double check that it wasn't originally a discontinuity. right? A discontinuity might break my intervals, and it might look on the number line like it's a maximum or a minimum, but if it was a discontinuity to begin with, there's no point there. I mean, it can't be a maximum or a minimum. It's a discontinuity. It doesn't exist, right? And so to check whether or not that point actually exists, we're going to take that -4 and we're going to plug it back into my f of x to say, do I get a y value? Because remember, y and f of x we use somewhat synonymously. Right? When I take that -4 and plug it into f of x, do I get a y value? Does that point actually exist on my graph? Okay? So I'm going to take that -4, I'm going to plug it back in here. I'm going to get 16 minus 32, which is -16, plus 10, which is -6, and negative times -6 is +6. Okay. Okay, so to demonstrate this process one more time, I went ahead and selected number 32. Number 32 says f of x equals x squared minus 3x minus 4 all over x minus 2. Okay. When I'm looking at this function, I do notice that in my numerator there, I could factor it if I wanted to. Personally, I'm going to choose not to, but you could. It might be advantageous if it's simplified. In this particular case, it won't though, so I'm just going to leave it. And so looking at this, we do notice, first of all, that there is a discontinuity. This discontinuity is at x equals 2. And so that x equals 2 is going to make its way onto my number line, because that might break up an interval. It might be where we change from increasing to decreasing, or vice versa. Okay, once I've located my discontinuity, I'm going to go ahead and take my derivative. We have low d high minus my high d low all over low squared. And I'm just going to clean this up a little bit. I'm going to expand these two quantities. We have 2x squared minus 3x minus 4x plus 6, and then distribute that negative. Once I've done that, I'm going to go ahead and combine some like terms here. We have 2x squared minus x squared, which is x squared. We have negative 3x plus 3x. They cancel each other out. So we're left with minus 4x, and 6 plus 4 is 10. Okay, so now that we've gotten there, we're going to be looking for our zeros, our critical numbers, as well as possible not differentiable spots. Down here in the denominator, I do have a discontinuity of 2 that's consistent with where I started, right? It was already a discontinuity. So when I set this equal to 0, the only thing I'm concerned about with a fraction is that that numerator equals 0, right? Because 0 divided by anything will still be 0. So for my critical numbers, I'm going to be looking there. And so when I look at x squared minus 4x plus 10, I have a choice I need to make. If it factors, I can factor. Or I could use quadratic formula. Or you could plug this into your y equals and then calculate your zeros. Okay. For this particular example, I'm going to go ahead and do quadratic formula. But again, you're more than welcome to put it into your y equals. In fact, I might recommend doing it both ways, so you are familiar with doing it by hand as well as in the calculator. Okay. So we've got x equals negative b plus or minus radical b squared minus 4ac all divided by 2a. Well, when I set that up, I get 4 plus or minus the radical of 16 minus 40. It means I'm going to have a negative under that radical. It's not possible. Right? So for this particular function, this means that I do not have any critical numbers, right? Because that isn't a point. You can't have a negative under a radical. And so for this particular problem, I'm only going to have one value that I'm putting on my number line, that 2. Okay, and I'm going to pick a number on both sides of the 2 and test it by putting those numbers as test numbers into my f prime. Okay. So for the 0, which is on the left, when I plug that into my f prime up here, I'm going to get a positive. And for my 3, when I take that 3 and I plug it in here, I'm also going to get a positive. And so for number 32, when we're asked on what intervals are we increasing or decreasing, we are increasing on negative infinity to 2, right, from negative infinity to 2, and from 2 to infinity. And with this particular problem, I have no decreasing intervals. There was nowhere where my derivative was negative. I've also got no maximums, because no hill is created, relative maximums I should say, and no relative minimums, because no valley was created. Okay, so I've only got 2 increasing intervals. And that's the first derivative test.